Hello, my name is Clemens. I'm the CTO of Persival, and today I'm going to give a short introduction to ASAM OSI Trace Files. In my last tutorials, I showed you how to effectively transfer data between simulation models using ASAM OSI. So we set up a co-simulation before, defined OpenScenario, OpenDrive as an input for that co-simulation, and then we looked into the interface between different models. If you've missed the previous tutorials, go ahead and watch them. And now we're continuing on the OSI front. Because OSI is not only an interface standard, it can also be used to store simulation data in so-called trace files. If you remember from the last tutorials, we have set up this co-simulation architecture using the AVL Scenario Simulator. Here we have esmini as a scenario player. We have an open source sensor model from OpenMSL, and we have a scenario recorder that is provided with the AVL Scenario Simulator. And between the different components, we have OSI as an interface, so the OSI sensor view message going from esmini to the sensor model, and the output of the sensor model is an OSI sensor data message. Both get recorded with the scenario recorder. There's also other trace file recording tools, open source available. I can put a link in the description below. Now, what the scenario recorder actually does is it takes the messages that it gets, the sensor view and sensor data, in each individual simulation time step, and it dumps them in a binary file. It's a .osi file, and that's the OSI trace file. And if we actually go to runs, we've had the replay before, right? So we see what's going on in the scenario. So we have this overtaking scenario, that's our ego vehicle, and we have one other vehicle, so two moving objects in that scenario. And here we can go to artifacts and to results and scenario replay. And here you can actually find these two .osi files. That's the sensor data OSI file, and that's the sensor view OSI file. It's a binary file, and you can load this with tools like this visualizer, or with the Persival SimSpector, or also other tools that can load binary OSI files, and you can replay the simulation. But you can also convert them to a human-readable format. There is a OSI2 read Python script in the official OSI repository, and you can run that over these binary files, and that will create a txt-h file. And this is a human-readable file of this binary OSI file. Let's actually have a look into that. So what you can see here is the structure of the messages. All the messages are here one after another underneath each other. And this is the first sensor view message. And the structure should actually look familiar because that's what we looked in the last tutorial in the OSI documentation. That's the hierarchical structure of the OSI messages. We have a timestamp here, and then we have the global ground truth message that contains most of the ground truth, most of the relevant data in the sensor view. And we have here a couple of stationary objects, but we can also have a look and see the moving objects. And here we will see a moving object with the ID 0, that's why it's empty, it's ID 0, and it has a certain dimension, has a certain position in that simulation time step. You see the orientation, the velocity, acceleration, and so on. You see that it is of type vehicle, it has a certain lane that it's assigned to, and so on. You can see individual wheels, where they are and how they move, and so on. And then we have the second moving object of ID 1. That is our target object. First one was our ego, that's our target. And again, you have dimension, position, and so on. And that's exactly the information that's transferred between the sensor model and the environment. or the other way around. The environment transmits it to the sensor model, and that's used by the sensor model. So you have the input and all this data that you then can calculate the sensor output from. And the whole interface is basically recorded in these trace files. So you can replay simulations. That's what's basically the scenario simulator does when you have the scenario replay. It reads in the trace files and replays the data that's in there. And you can also use that to feed into new running simulations. So now that we've recorded the scenario, if we just want to play it again, or if we do changes to our sensor model, for example, and we just want to feed exactly the same sensor view in as before, we can store the sensor view, and then there's open source tools available to play that back. So there's trace file players available that read in a trace file and time step by time step play it back to the sensor model. This way you can replay exactly the same scenario, exactly the same simulation, environment simulation over and over again in a sensor model during development, for example, or for validation. You don't need an environment simulation to validate a sensor model. You can simply use OSI trace files and feed exactly the same data into the model over and over again. That's a major benefit of this standardized interface and also the standardized file format we have here. That's it about the trace file format. In the next tutorial, I will go into more advanced modeling techniques and a standard that's needed for that, and that's OpenMSL 3D. For now, the model I showed here, the sensor model, was a very simple one, just based on simple object lists. And now we're going into more advanced models, into more advanced simulation where you have whole entire 3D worlds in your simulation, where you have material parameters in your simulation. All of that can be used for sensor simulation. And that will be the topic of the next tutorials. So stay tuned for that. If you have any questions about OSI, about the trace file format, feel free to leave a comment below. See you next time.